Hello, this is Group 5 performing Group Lab Activity 4 for the course EEO 3110C. My name is Naya Sanchez Lucero and my Panther ID is 6115497.
Hello, my name is Sergio Gomez and my Panther ID is 2832878. And today is 6/6/2022. Okay, so for activity 1, we're supposed to set up a 741 operational amplifier with VCC and VEE equivalent to 12 volts, well, 10.4 volts. We decided to set it to 12 volts. And R1 is 1 kilo ohms and R2 is 2 kilo ohms. In our actual setup, once we have it here in multi-sim, you can see the amperages. What was interesting, of course, is that since we don't have an input voltage into the positive sign of the 741 operational amplifier, the amperage going from PR1 into PR5 is basically the equivalent amperage. So we have -4 milliamps on one side and -4 milliamps on the other. What is interesting is that V sub O, or output voltage of the operational amplifier, is set equivalent to the VCC and VEE, that is 12 volts, which in my mind means that the operational amplifier is not actually amplifying anything since we don't have an input voltage going into the positive terminal of the operational amplifier. Along with this, I'm going to go ahead and show you our Excel sheets. So I1 is -4 milliamps, I2 is -4 milliamps, I3 is 158 nanoamps, I4 is -12.5 picoamps, I5 is -4 milliamps, I6 is -29.4 milliamps. Now, I7 and I8, those are peak-to-peak numbers for our amperage. Since the actual traditional amperage ends up being infinity. Those are 700 milliamps on the average. VCC and VEE are 12 volts respectively, and then V sub O is also 12 volts. Now, when I say VEE is 12 volts, I actually mean it's the negative 12 volts, since that's an operational amplifier requires a positive and negative going into the circuit. So that is an actual negative 12 volts, and that ends up producing a V sub O where it is 12 volts. Thank you.
So for activity 2, we have this circuit here. And for the voltage source, we set it equal to 5 volts. And as you can see, there's no resistors in this circuit. So the output voltage is going to also be equal to 5 volts because there's no voltage division, no voltage amplification, and because there's no resistors, there's no gain factor, so the voltages are going to be the same.
For activity 3, we were supposed to set up 2 operational amplifiers feeding into each other. Within this circuit, we have 2 741 operational amplifiers. The first one has an input voltage or DC voltage of 5 volts. We set VCC for both the circuits to 12 volts, as is visible by V sub 1 and V sub 2, which are acting representative of VCC for these circuits. The first operational amplifier doesn't actually have any input into the voltage output because there's no resistors to change gain. So, but now going into the second one, we have an inverting amplifier since it changes the input voltage to an output voltage, and that is just simply R sub 1 divided by R sub 2 negative. So for our first case, with our input voltage of 5 volts, we see V sub 01 as equal to 5 volts as assumed, since that would be the input output with no resistance changes, no gains. Now it goes through this R sub 1 resistor going into the circuit here for 741U2. 741U2 is set up as an inverting amplifier with a resistor 1 of 1 kilo ohms and resistor 2 of 1 kilo ohms equivalent to each other. So what ends up happening here is we have a V sub O2 of -5 volts. This correlates since this is an inverting amplifier, so therefore our output voltage from the entire circuit is -5, or the inverse of what the input voltage was. For the second setup, we went ahead and set up R1 to be greater than R2, and in this case factor, the gain across the circuit ends up being -0.5. Since we have 1/2, that ends up creating a circuit where our gain function is -0.5. So our output voltage ends up being -2.5 volts, since our input voltage is 5 volts. And then for case 3, we have a R sub 1 is less than R sub 2, so we went ahead and set R sub 1 equal to 1 kilo ohms, R sub 2 equal to 2 kilo ohms. Everything else staying the same, our output voltage ends up going to -10, which makes sense because once again, our gain is equal to 2 volts, -2 volts. So our input voltage of 5 volts gets amplified up to -10 volts. Well, yes. Now I can show these on our Excel spreadsheet. So R sub 1 equals R sub 2, or our V sub DC is 5 volts, V sub 1 is 5 volts, -5 volts for V sub 2. With a gain of -1, and then our second case, R sub 1, R sub 2 is 5 volts, V sub 1 is 5 volts, and as this is halved, -1/2, so V sub 2 is -2.5, which goes in line with our gain of -0.5. And then lastly, R sub 1 is less than R sub 2. So we have 5 volts, -10 volts with a gain function of -2. Thank you very much.
To conclude lab activity 4, in activity 1, here we see a circuit with resistors, and you would think there would be a circuit gain, but since there's no input voltage, the output voltage would not change. And because circuit I5 and circuit 1 are the inverse of each other, that further proves that there's no change in the circuit, and that's why there's no circuit gain. And V0 is equal to VCC. For activity 2, here we actually have input voltage, but there's no resistors, so again, there won't be any circuit gain, and the output voltage is going to be equal to the input voltage. For activity 3, we have an overcomplicated optional amplifier. So for this first half of the circuit, it's the same as activity 2. There's no resistors, so there'll be no circuit gain. The first output voltage is equal to the voltage input source. And that voltage feeds into this amplifier, so it's going to be an inverting amplifier. And as we change the values for R2 and R1, that also affects the output voltage because it'll change the gain factor. And that's all for lab activity 4.